So let's do just a short video for, this is in your book, problem 4.35, for the Introduction to the Practice of Statistics book. So it tells us that we know 7% of the U.S. population has type O negative blood, and we want to know that what is the probability that out of 10 people, at least one person will have type O blood. Now you could try and do this problem directly, which would mean you would have to list out all of the possible outcomes that you could do to get at least one person with type O negative blood. So let's do an O for type O negative and an X for not type O negative. So let's just say I wanted one person to have type O blood. I could do the first person be type O negative and the next person not. Okay, so you would have to have one person type O negative and 9 people with not type O negative. But that's not the only way to do it. You could also have not type O, and then not, okay, etc. So notice there would be lots of different ways I could get just one person with type O negative blood. But then you'd also have to consider, well, how could I get 2 people with type O negative blood? So I could have like a type O, and then not. Or I could do not, type O negative, not, etc. I would have to list out all the different ways that I can get at least one person with type O negative blood. And it so happens that there are going to be 1,023 possible ways that you can get at least one person with type O negative blood if you're looking at 10 people. That's going to be a lot of different outcomes for you to list out and find the probability for each one and then add them all up. That is going to take a really long time. We don't want to do it that way. We want to use the complement. So the complement of at least one person is no people with type O negative. So what we need to do is to find the probability of at least one, we're going to do 1 minus the probability of none. But to do this, to find the probability of no people with type O negative blood, you need the first person to be not type O. Now, if there's 7% chance to get type O negative, then the probability of not type O negative is 0.93. But that's just for the first person. You also need the second person to have not type O negative, and the next person to have not type O negative, and the fourth person to have not type O negative, and the fifth person, all the way up to the 10th person. Now the reason we multiply is we need the first person to have not type O negative, and the second person to have not type O negative, and the third person to have not type O negative. And anytime we have the word "and" in statistics, we will multiply our probabilities. So this is really 0.93 to the power of 10, because we need 10 people to have not type O negative blood all at the same time. So 1 minus 0.93 raised to the 10th power gives me 0.51, sorry, let's redo that instead of skipping steps. So let's do 1 minus, so if I just do 0.93 raised to the power of 10, I get 0.4839. So it appears that the probability of getting no people with type O negative blood is 48%. So if we want to find now the probability of at least one person with type O negative blood, we're going to use the complement rule and do 1 minus 0.4893, which gives me 0.5107. So we have now that the probability of getting at least one person with type O negative blood is about 51%. Again, we used the complement rule here because it would have taken us a really long time to do it directly, because again, we would have had to find the probability for 1,023 possible outcomes and added up all of those probabilities. So instead we used the complement rule, 2 calculations, and we were done.